All right. Hi, everyone. My name's Andre Wong. I'm actually an engineer at the Department of Astronomy. Jarron Leisenring was supposed to be giving this talk today, but he was called into a NASA review, so he asked me to give this talk. So I'll be talking about the Arizona Infrared Detector Lab. So that's kind of a new initiative that we're starting up at Steward to kind of centralize some of the infrared detector work that we've been doing there, and also bring in and help support some of the other projects around the lab around the campus that require infrared detectors. So this is kind of filling in the work that's been previously done on NIRCam and all the work that the Rikis have done and kind of take it to the next generation. So right now there's kind of three primary personnel that's involved in getting the lab up and running. So myself, Jarron Leisenring, an assistant research professor at the astronomy department, and Stuart, and also Brittany Miles, who's a postdoctoral fellow. So the three of us have kind of varied but complementary interests around infrared detectors. So Jen was a part of the JWST NIRCam instrument team. His kind of main research interests are infrared detector for high contrast imaging. So this is imaging of protoplanetary disks and planets around distant stars. And then also Brittany, she's on the Scales instrument team and also part of some of the JWST early release imaging programs for planets as well. And then myself, I have an engineering background, so my main interest is in infrared detectors and kind of spaceflight applications for them, making sure that we can get them up and running, and then also make sure they get the performance that various PIs need for their missions. So the primary goals for the lab that we're starting, we have kind of three main thrusts. One is kind of study of infrared detectors themselves. So this is kind of on the engineering side and on the science side. So on the engineering side, this is mainly to get them ready for space, make sure they're qualified, do the environmental testing, make sure they survive the rigors of space flight. And then we also have a lot of, we also want to put in a lot of effort on the characterization side. So making sure the sensors perform at the levels that the scientists need them to get all the information that we need for them. That way, when they actually get science data off the detectors, the scientists are able to interpret that data properly. This is kind of on both the mature side of infrared detectors that exist already, and we also want to focus on developing technologies around infrared detectors for the next generation of missions. Our second goal is to kind of more on the implementation side for these detectors. So this is basically finding PIs and scientists around campus that want to implement these both as larger instruments. So these are instruments that will either go in observatories or go up in space, or also smaller cameras. So these are kind of like context cameras that might be used for surface missions on the moon and things like that. So it it ranges from large instrumentation to do large science projects to smaller cameras that are mainly used for very specific needs on very specific or very broad needs of different missions. And then finally, we're hoping to expand the technical expertise around infrared detectors. We recognize that infrared detectors are very important for many different fields of science. Obviously, astronomy, which is what we're interested in, but also for earth science and planetary science and geology and everything. We also recognize that with the advent of larger constellations for Earth observing, that more and more detectors are needed, and therefore we want to both develop the engineering talent here and also foster undergraduate and graduate students that they may go on to productive careers in detectors. Currently, as I mentioned, we're in the startup phase. We are currently looking for permanent lab space. We do have some temporary lab space that we have available for various projects, but we're looking for a permanent home. That way we can set up the proper facilities we need. As many of you know, doing things for space requires a lot of hardware and equipment and stuff. So we want to make sure we get something set up there. We are currently procuring a low temperature cryostat for infrared testing. This should cover a lot of the needs that we need for startup, but we also hope that as we gather more and more projects that we add capabilities, add equipment. That way we can use those pieces of equipment to support further projects. And then finally, there's a lot of equipment that was left over from previous missions, namely JWST. So they spent a lot of money developing all this equipment. So one of the key piece of equipment was a metrology cryostat for doing metrology on these detectors. So we want to make sure that all that equipment is still being used and we can apply that to future missions. Collaboration. So as I mentioned, what we want to do is find collaborators around campus who are interested in using infrared detectors and then work with them in order to make sure that we can get their detectors onto missions and make their missions successful. So this, how we want to do this is providing a deep understanding of these detectors. A lot of times the scientists are interested in the science, but they may not have a deep understanding of how these detectors work and limitations and positives of different detector technologies. So we want to provide that consultation experience to those PIs. We want to help them on developing proposals. Um, as we've been talking here, proposals are very important in winning future projects here. So we want to support on the detector side and also on the system engineering side, making sure that these detectors get integrated properly with the rest of the mission and the rest of the project. And then once we win those proposals, we want to use our lab space, staff, and our expertise in order to make sure we can implement these and build the hardware that we can get in this space. And then kind of more on the looking ahead side, we want to focus on technologies and look ahead to future technologies and also future missions that may depend on these technologies and make sure we bring together these PIs and these technologies to make sure that we can get them developed for future use. All right. And then in summary, so Stewart Observatory, we have a long background in infrared detectors. So all the way back, I think the 70s or the 80s. So we want to make sure we continue that tradition here at UA as a leader in infrared technologies. So with this lab, we want to continue to advance infrared detector technologies, enable new novel capabilities that don't really exist now, but are kind of in the concept stage. We want to help PIs deliver infrared instruments and also write proposals to win them. And then also form partnerships with other groups. I know Erica and Walt do a lot of UV work, and then Mike Lesser's group is working in the visible. So we want to make sure we span the full wavelength range here at UA. And then finally, we want to emphasize that we are very interested in training the next generation of engineers and students for whatever they may go on to. Thank you.
Thanks a lot, Andre. Do we have any questions?
Thank you for your presentation. What kind of calibration methods do you have, and how do you think about training the next career or next generation people in instrument calibration?
So the calibration methods will vary depending on the mission. So if you were, for example, trying to use an infrared camera to look at lunar regolith, that kind of calibration is different than what JWST is using for the science. So what we want to do is work with the scientists and the PIs to figure out what they need to do in terms of observations and what they're looking at, and then determine the best way to get together a calibration plan for those projects. So there's not a single answer, but really it's the partnership that we have with the scientists and what they need to do, the scale of what they need to do, time, budget, things like that, so we can get together a customized calibration plan for specific projects.
All right, any other questions? All right, thank you again, Andre.